All right, good morning. Unit 10, Classwork 8, Properties of Chords. Today we're just going to go over the rules for chords that we learned last time. And let's start with some prior knowledge. So given the diagram to the right, KL, if you look at that, clearly that is the radius. I need to change my pen color. So clearly that is the radius of this circle. Find the length of LK and round to the nearest tenth. So I'm going to redraw this out here. We've got 3, and properties of chords tell us if we've got the perpendicular bisector, then we can cut that 14 in half. That makes this 7. And in order to find R, we use Pythagorean theorem. R equals 3 squared plus 7 squared. It asks us to round to the nearest tenth. So plugging that into our calculator, R equals 7.6 centimeters. What is the measure of KLN? I'm going to draw it out again. And I want to remind you, when we do this, let's not use the 7.6 number because it's a rounded number. So you don't want to put a rounded number into a trig ratio. But if you have to, you have to. That's when you would carry out your decimal to more than a tenth. So we want to find this angle right here. So let's go ahead and put a theta in there, and we can use inverse SOHCAHTOA. In fact, that's opposite over adjacent, so that is inverse tan of rise over run. Remember, tangents always slope angle. Plugging that in, it says to the nearest whole degree. Then we know that angle KLN equals 23 degrees. Number 2, find chord WX in circle Z. If WX equals 8 and the radius of circle Z equals 5, how far from the center is the chord? So what we're looking at is, how far is this? Well, on these diagrams, you're going to have to sometimes draw in parts that aren't there. And so if we draw in our radius, we know each radius is 5, and this whole length here is 8, and we can cut that in half, and that is 4. What do we know the length of the distance that the chord is from the center? Well, that's our classic length equals 3, because that's our 3, 4, 5 right triangle that we've been seeing all year. All right, prior knowledge. Actually, this whole lesson is prior knowledge. We're just going to add a little bit more onto each of those in practice so that you get one more chance in homework. All right, properties of chords of a circle. The first property is right here. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So we've got the arcs congruent, which means the chords are congruent. This property goes either direction. It's true either way. So notice, and you've been making some of these mistakes on your warm-ups. You'll go, oh, let me just find x. 3x minus 7 equals 2x plus 1. I'm going to move the 2x over. add 7 to both sides, and I have x equals 8, and you go on to the next problem. But that's not what the question asked. Find PQ. So you have to plug it in. So 3 times 8, 24, 24 minus 7, PQ equals 14 units. If you don't want to subtract, you know that NP or MN, sorry, not NP, MN is the same length. You could go, hey, 2 times 8 is 16 plus 1 is 17. Why did I write 14 there? That's crazy. Just said 17. All right, here we go. And if AC right here is 150 degrees, and we know that AB and CB are both the same length, then we know these arcs are the same length. So 360 minus that 150, that's 210. 10 divided by 2 is 105. So AB is 105 degrees. All right, so take a second. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent, and the converse if that is true, meaning the opposite. All right, in a circle, if a radius or a diameter is perpendicular to a chord, then it bisects the chord and its arc. So we want to know the length of CE. Well, if C to F is 5, then F to E must be 5. So CE must equal 10. And we want to know the measure of CE. So again, this is one of those where you find X and then plug in. So we know that X equals 80 minus X. Add X to both sides. 10X equals 80. X equals 8. So 7 times 8 is 72 degrees. 80 minus 8 is 72 degrees, and 72 plus 72 is 144 degrees. And the last rule we're going to study, and that is in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So CV and CU are congruent. We can set them equal to each other, but we've got some more information here. QR equals ST, and they both equal 16. Let's find X first, and then let's go look for the radius. We might need to draw some pictures here. So here we go. Let's start with 5X minus 9 equals 2X. We're going to move the 2X to the left side of the equal side and the 9 to the other. We're going to have 3X equals 9, X equals 3. All right, so this length here is 6. Let's draw that. We're looking for the radius. I know this length is 6, and it said QR equals ST equals 16. But if we are going to do this, we want half of that 16. So we're going to put 8 here. And the radius equals the square root of 6 squared plus 8 squared. And you should know that that is 10 units. And that's just a scaled up version of our 3, 4, 5. So we'll practice a few together because we're going to make them a little tricky for you. All right, measure of AOB. AOB. Well, you've got two radii and you've got a central angle and you've got an intercepted arc. So I know that the angle AOB must equal 86 degrees. And let's see. Oh, measure of OAB. Look at how I switched that. All right, here we go. Now we're looking at this angle right here. I'm going to darken it in. OAB. So, what's half of 86? 43. And we know that the two acute angles in a right triangle are complementary, meaning add up to 90 degrees. And so that angle that I just highlighted would be 47 degrees, making theta 43 degrees. And 43 and 47 add up to 90. Length OA. Well, let's see. I have a diameter that's 28, which means I'm going to have a radius. My diameter equals 28, which means my radius equals 14. So I want to know the length of OA. OA happens to be a radius. So that's 14 units. But now they want the length of AD. So let's draw that out. I know this is 14, the radius. And I know that this angle is 43 degrees. And I know that we want this, A to D. So using SOHCAHTOA, it looks like opposite over hypotenuse. So that's sine. Sine 43 degrees equals x over 14. Plug it in, we'll go ahead and round to the nearest tenth. And so AD, which is x here, is 9.5 units. Next problem. We want to find x to the nearest tenth. Well, let's see. X is a radius, and this is one of those problems where you're going to have to recognize that that radius can swing around because all radii are the same length. This is also x. And that 8 can be broken in half for 4. And then again, once again, these problems aren't that tricky. 3, 4, x equals 5. You're always looking for the 3, 4, 5, 6, 8, 10, and 5, 12, 13 right triangles, because those are like your Pythagorean triples. Let's find the value of x to the nearest tenth. So in this case, our radii is 16. There's our radii, it's 16. And do you notice that we have a central angle here? And that central angle will also equal 75. Right here, this little angle right here is 75 degrees. So I'm going to redraw that off to the side. I have 75 degrees. I have 16, and we want X, and X would be this length. Another circuital problem. It looks like I can use sine again, opposite over hypotenuse. So I'm going to do sine of 75 degrees is X over 16, doing my cross product, rounding to the nearest tenth, X equals 15.4. So trig, draw in radii, sometimes we'll draw in chords, and Pythagorean theorem. All right.